NFPA 70, also known as the National Electrical Code, in Section 630.23, paragraph B, addresses the bonding requirements for portable equipment. Specifically, it states that metallic equipment, whether fixed or portable, must be bonded to the grounding system as specified in Section 250.110. This bonding is typically achieved through a connection to the grounding conductor within the flexible cord. However, there are exceptions to this general rule. Exception number 1 states that a separate grounding conductor is not required for portable cord and plug-connected tools and similar appliances. Exception number 2 provides an alternative scenario. It states that for portable tools and appliances that are not cord and plug connected, and where a separate flexible equipment grounding conductor is not utilized, the frame or casing of the tool or appliance must be grounded by a separate grounding conductor run alongside the circuit conductors. This grounding conductor can be run inside a non-metallic raceway or a metal auxiliary gutter. Applying these code provisions to the specific case of portable cord-connected, three-phase delta welders used in wet environments, the second exception could allow the use of a separate equipment grounding conductor. This allowance stems from the fact that welders with the delta configuration may not be considered cord and plug connected in the traditional sense, thus necessitating a separate grounding conductor. The intent behind these regulations is to enhance safety, particularly in environments where the risk of electrical shock is elevated, such as wet locations. By providing a redundant grounding path, the likelihood of a hazardous voltage being present in the equipment's enclosure is reduced in the event of a failure in the primary grounding conductor. It is important to consult with a qualified electrical inspector or engineer to ensure that any installation complies with all applicable codes and standards. Furthermore, it is essential to implement a robust maintenance and testing program to verify the integrity of all grounding conductors, both those within the flexible cord and any supplementary grounding conductors that may be installed. This program should include regular inspections and testing to identify and address any potential issues before they can lead to an electrical incident. When dealing with electrical equipment in potentially hazardous environments, it is always better to err on the side of caution and take all necessary precautions to protect personnel from electrical shock hazards. Grounding is a critical safety measure that plays a vital role in preventing electrical accidents and ensuring the safe operation of electrical equipment. Understanding the NEC requirements for grounding and bonding is essential for anyone involved in the design, installation, or maintenance of electrical systems. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements and best practices. Consulting with qualified professionals and participating in continuing education programs are excellent ways to ensure that you have the knowledge and skills necessary to work safely with electricity. By adhering to the NEC and implementing sound electrical safety practices, we can create a safer working environment for everyone. The NEC provides a comprehensive set of rules and guidelines for electrical installations, covering a wide range of topics from wiring methods to overcurrent protection. It is important to familiarize yourself with the specific requirements that apply to your particular application and to follow them diligently. Grounding is just one aspect of electrical safety, but it is a critical one. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protective device and to energize the circuit. This can prevent electrical shock, fire, and equipment damage. In addition to following the NEC requirements, it is also important to use high-quality electrical components and to install them properly. Faulty or improperly installed components can compromise the safety of the electrical system and increase the risk of electrical accidents. Regular inspections and maintenance are also essential for ensuring the continued safe operation of electrical equipment. Look for signs of damage, wear, or corrosion and address any issues promptly. By taking these steps, you can help to create a safe and reliable electrical system that will protect people and property from harm. Let's delve into grounding a bit deeper. Grounding, in electrical engineering, is the intentional connection of a conductive object to the earth or to some conductive body that serves in place of the earth. It's a fundamental safety measure in electrical systems, designed to protect individuals from electric shock and to prevent damage to equipment. The primary purpose of grounding is to provide a low impedance path for fault current to flow back to the source. This low impedance path allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and energize the circuit in the event of a fault, such as a short circuit or a ground fault. Without a proper grounding system, a fault current could flow through unintended paths, such as the human body, which could result in serious injury or death. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding involves connecting the non-current carrying metal parts of electrical equipment, such as enclosures, raceways, and motor frames, to the grounding system. This ensures that these metal parts are at or near ground potential, which minimizes the risk of electric shock if a fault occurs. System grounding, on the other hand, involves grounding one of the current carrying conductors of the electrical system, typically the neutral conductor, in a single-phase or three-phase system. This helps to stabilize the voltage of the system and to provide a reference point for fault detection. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. Section 250 of the NEC covers grounding and bonding, and it is essential for electricians and electrical engineers to be familiar with these requirements. The NEC specifies the types of grounding electrodes that are permitted, the methods for connecting to grounding electrodes, and the requirements for grounding conductors. Some common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC also requires that all grounding connections be made with approved connectors and that the grounding system be properly tested to ensure its effectiveness. Bonding is another important concept in electrical safety. Bonding involves connecting together all of the metal parts of an electrical system to create a continuous electrical path. This path helps to equalize the potential between different metal parts, which minimizes the risk of electric shock if a fault occurs. The NEC requires that all metal enclosures, raceways, and other metal parts of an electrical system be bonded together. Bonding can be achieved using various methods, such as bonding jumpers, bonding bushings, and bonding locknuts. It is important to ensure that all bonding connections are properly made and that the bonding system is properly tested to ensure its effectiveness. Ground fault circuit interrupters, or GFCIs, are another important safety device that is used to protect against electric shock. GFCIs are designed to detect small amounts of current leakage to ground and to quickly trip the circuit, preventing electric shock. GFCIs are typically required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. It is important to test GFCIs regularly to ensure that they are functioning properly. Electrical safety is a critical concern in both residential and commercial settings. By following the NEC requirements for grounding and bonding and by using safety devices such as GFCIs, we can minimize the risk of electric shock and prevent electrical accident. Remember to always work with a qualified electrician when performing electrical work and to never attempt to repair electrical equipment unless you are properly trained and qualified. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Let's look at some specific scenarios involving grounding and bonding. In a residential setting, the grounding system typically consists of a ground rod that is driven into the earth near the service entrance. The ground rod is connected to the service neutral conductor and to the metal enclosure of the electrical panel. All of the branch circuits in the house are then grounded back to the electrical panel. In a commercial setting, the grounding system may be more complex, depending on the size and type of building. The grounding system may include multiple ground rods, a ground ring, or a connection to a metal water pipe. The grounding system must be designed to provide a low impedance path for fault current to flow back to the source. Bonding is also important in commercial settings. All of the metal parts of the electrical system, such as conduits, cable trays, and equipment enclosures, must be bonded together to create a continuous electrical path. This helps to equalize the potential between different metal parts and to minimize the risk of electric shock. In industrial settings, the grounding system may be even more complex. due to the presence of large motors, transformers, and other heavy equipment. The grounding system must be designed to handle the large fault currents that can occur in industrial settings. Bonding is also critical in industrial settings, as is the use of surge protection devices to protect equipment from voltage transients. Surge protection devices are designed to divert surge current to ground, protecting sensitive electronic equipment from damage. Proper grounding and bonding are essential for electrical safety in all types of settings. By following the NEC requirements and by using appropriate safety devices, we can minimize the risk of electric shock and prevent electrical accidents. It is also important to remember that electrical systems should be inspected and maintained regularly to ensure their continued safe operation. Now let's talk about some of the common grounding mistakes that people make. One common mistake is to assume that the neutral conductor is always at ground potential. While the neutral conductor is typically grounded at the service entrance, it is not necessarily a ground potential throughout the electrical system. Voltage drops can occur along the neutral conductor, which can result in a difference in potential between the neutral conductor and ground. Another common mistake is to use the wrong size grounding conductor. The size of the grounding conductor must be adequate to carry the maximum fault current that could occur in the circuit. The NEC provides tables that specify the minimum size grounding conductor for different circuit sizes. It is important to consult these tables and to use the correct size grounding conductor. Another mistake is to make poor grounding connections. Grounding connections must be clean, tight, and corrosion resistant. Loose or corroded grounding connections can increase the impedance of the grounding path, which can reduce the effectiveness of the grounding system. It is important to use approved connectors and to follow proper installation procedures when making grounding connections. Another mistake is to neglect to bond all of the metal parts of the electrical system together. Bonding is essential for creating a continuous electrical path and for equalizing the potential between different metal parts. All metal enclosures, raceways, and other metal parts of the electrical system must be bonded together. Another mistake is to fail to test the grounding system after it has been installed. Grounding system testing is essential for verifying that the grounding system is properly installed and that it is providing a low impedance path for fault current to flow back to the source. Grounding system testing should be performed by a qualified electrician using appropriate testing equipment. By avoiding these common grounding mistakes, we can help to ensure the safety and reliability of electrical systems. Remember to always follow the NEC requirements and to consult with a qualified electrician when performing electrical work. Here are some additional tips for ensuring electrical safety. Always turn off the power before working on electrical equipment. Use insulated tools when working on electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical equipment in wet or damp conditions. Inspect electrical cords and plugs regularly for damage. Replace damaged cords and plugs immediately. Use ground fault circuit interrupters, or GFCIs, in areas where there is a high risk of electric shock. Test GFCIs regularly to ensure that they are functioning properly. Never overload electrical circuits. Use extension cords sparingly and never run them under rugs or furniture. Keep electrical equipment away from flammable materials. Install smoke detectors and carbon monoxide detectors in your home. Test smoke detectors and carbon monoxide detectors regularly to ensure that they are functioning properly. Develop an emergency plan in case of an electrical fire or other electrical emergency. Know how to shut off the power to your home in case of an emergency. By following these electrical safety tips, you can help to protect yourself and your family from electrical hazards. Remember that electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical accidents. The information provided in this narration is for general educational purposes only and should not be considered as professional advice. Always consult with a qualified electrician or electrical engineer for specific guidance on electrical installations and safety. Electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements and best practices. Continuing education programs and industry publications are excellent resources for staying informed about electrical safety. By taking the time to learn about electrical safety and by following safe work practices, we can create a safer environment for ourselves and for others. Let's discuss Assured Equipment Grounding Conductor programs. An Assured Equipment Grounding Conductor program is a safety program designed to ensure the integrity of equipment grounding conductors on portable electrical equipment. This is particularly important in environments where equipment is subject to frequent movement, rough handling, or exposure to moisture or other contaminants. The purpose of an Assured Equipment Grounding Conductor program is to prevent electrical shock hazards by ensuring that equipment grounding conductors are properly connected and in good working condition. The program typically includes regular inspections, testing, and maintenance of equipment grounding conductors. Inspections should be conducted by qualified personnel who are trained to identify potential hazards. Testing should be performed using appropriate testing equipment to verify the continuity and integrity of the equipment grounding conductor. Maintenance should be performed as needed to repair or replace damaged or worn equipment grounding conductors. The frequency of inspections, testing, and maintenance will depend on the type of equipment, the environment in which it is used, and the frequency of use. Equipment that is used in harsh environments or that is subject to frequent movement may require more frequent inspections and testing. The Assured Equipment Grounding Conductor program should be documented in writing and should be readily available to all employees who use portable electrical equipment. The program should include procedures for identifying and correcting deficiencies, as well as procedures for training employees and the proper use and maintenance of portable electrical equipment. In addition to inspections, testing, and maintenance, the Assured Equipment Grounding Conductor program should also include procedures for selecting and using appropriate portable electrical equipment. Equipment should be selected based on the specific application and should be rated for the environment in which it will be used. Extension cords should be used sparingly and should be properly sized for the load. Ground fault circuit interrupters, or GFCIs, should be used in areas where there is a high risk of electric shock. Employees should be trained on the proper use of portable electrical equipment and should be instructed to report any problems or concerns to their supervisor. The Assured Equipment Grounding Conductor program should be reviewed and updated periodically to ensure that it remains effective. The program should be revised as needed to reflect changes in equipment, environment, or regulations. By implementing an effective Assured Equipment Grounding Conductor program, employers can significantly reduce the risk of electrical shock hazards and create a safer working environment for their employees. This is especially important in industries where portable electrical equipment is used extensively, such as construction, manufacturing, and maintenance. Remember that electrical safety is a shared responsibility. Employers are responsible for providing a safe working environment, and employees are responsible for following safe work practices. By working together, we can prevent electrical accidents and ensure the safety of everyone in the workplace. In summary, when dealing with portable welders, especially in wet environments, understanding and applying the NEC guidelines for grounding is crucial. While the code generally mandates grounding through the flexible cord, exceptions exist, particularly for equipment not strictly cord and plug connected, like some three-phase delta welders. In these cases, a separate equipment grounding conductor is permissible, enhancing safety by providing a redundant grounding path. This redundancy is vital in wet conditions, where the risk of compromised grounding increases. Regular inspections, testing, and a robust maintenance program are essential to verify the integrity of both primary and supplementary grounding conductors. Consulting with qualified electrical professionals ensures compliance with all applicable codes and standards, keeping the workplace safe and preventing electrical accidents.